Hi guys, today we're gonna be talking about electric planets. So let's see what's up. For introduction, the purpose of this experiment is that we're gonna be using electric force instead of gravitation for a spaceship to move around the sky with planets and moons. It's gonna be crazy. For our fundamental physics principles, we have electric force, which is Fe equals the k times the charge q times second charge of a second object q2 over a radius. Gravitational force is going to be very similar. Fg equals big G times mass 1 times mass 2 over distance square. We're going to be using Newton's second law, which is that the F net equals a change in momentum or a change in time. And our results, you can see that not everything is exactly very accurate. We'll get to that. Oh, there's a gravitational, cool. So for methodology, the first step, we're gonna make a crazy code. It's gonna have a normal planet and a normal moon, and then a ship that's gonna just go absolutely crazy with some electric forces. And from this, we're gonna get some very pretty results. So we're gonna enjoy them. So how was the code developed? Well, first we need some initials. So for the initials, we have the value of k, which is 9 times 10 to the 9. System is going to vary. First system is going to be the moon, with the surroundings being the planet so that the moon can orbit the planet. The second system is going to be the ship, with the moon and the planet as the surroundings, so the ship can move in its normal movement. And then we're going to have some Q charges for the planet, moon, and ship. The charge of the electron and proton is just for comparison. And we're going to change around those Q values for fun. As you can see, they're very large compared to the electron and proton charges, which we'll get to later. For the actual calculations, we used position update and velocity update for the program to know where the planet and where the moon and the ship were at different time intervals. And for that, we have to calculate each individual force that the ship exerts on the moon, that the planet exerts on the moon, that the planet exerts on the ship, and that the moon exerts on the ship. And in addition to that, our ship is going to be affected by the electric charges of the planet and the moon. So we also have to calculate that force and take it into consideration when we're doing the F net on the ship. For our results, so for the first one, we have the Q's at their values times 10 to the 10, and the ship doesn't really seem to care. It just goes away wherever it wants to. Doesn't really get affected by it. In these examples, as we can see, the planet and the moon have positive charges and the ship has a negative charge. Try to make the ship have an attractive force with them. And so for the second one, we go up to 10 to 14. And so the ship gives a curve, neat curve, nothing crazy. Then we go up to 20, and the ship is just gone. It's away. So as you can see, the scaling of electric charges is much crazier than gravitational. And just for funsies, instead of the ship being negative, the moon is negative and the ship is positive, then your ship just does that and crashes into the planet, but crashed way too hard and it just left the planet too. You can have fun with that. There's some very crazy stuff that happens when you do. So for an errors, those queues were just insanely large. Yeah, I guess ChatGPT was what an average queue it was, and after he jabbed for a long time, oh yeah, between 10 to the negative 9 and 10 to the negative 3C. So those charges that are just 10 to 10 are just absolutely insane. ChatGPT says you can move mountains with that. That's crazy. So what does it mean that, what are those crazy shapes? Basically just that electric charges are much larger compared to gravitational force. And we can see that the Q just being much bigger than the G, about a difference of 10 to the 20. So what if we use realistic charges for our electric forces? Then the electric force won't do anything. Because planets and moons still have electric charges, they're just neutral. And that's sad. So in conclusion, don't use electric forces to power your rocket. It's just gonna cause chaos and you're realistically not gonna get the charges that you want. But if you do get some crazy things and you can go really, really fast. So actually do try it out. I wanna see that.